Alright, building off of 1.2, let's understand the reasons for the seasons. I'm going to identify 4 reasons for the seasons. Of course, a lot of this could be reviewed for some of you, but let's start off with revolution as our first reason for the season. Revolution, of course, the Earth revolves around the Sun. That voyage takes 1 year, 365.25 days. 0.25 days explains the leap year, the reason why we have it. And we're currently moving at 66,000 plus miles per hour, but of course we don't feel that because of the pull of gravity. Our second reason for the season would be rotation. Earth rotates on its axis once every 24 hours. One of the things is we have, at all times on Earth, we have 50% day, 50% night. And so that line that separates 50% day from 50% night is what we call the Circle of Illumination. And so the Circle of Illumination is the edge that divides half of the Earth with daylight and the other half. Here's a cool map that shows half the world at night and half the world during the day. This is current. If you visit at any time, it shows real time. And one of the things is you notice it's kind of funky looking because it uses a Mercator projection, which is, once again, you have to have a round ball and you have to put it on a flat piece of paper. Building off of our Earth-Sun relationships image here, we can now add the fact that we have the Circle of Illumination. We've got the one half of the world that's at night, and the other half that's currently in the day. Reason number 3 for the seasons is the fact that the Earth is slightly tilted. The Earth is tilted 23.5 degrees from the plane of ecliptic. 23.5 degrees, you'll see that number pop up a few different times. This is very important because if there was no tilt, there would be no seasons. And so the third reason is one of the key reasons for the seasons. Here we have Earth at a 0-degree tilt, and so it's perfectly straight up. And so what I said, Earth, I'm going to tilt you 23.5 degrees. And this is the result. So here's what Earth looks like in representation to the Sun. It's at a 23.5 degree tilt, so we can get rid of those previous red lines. The fourth and final reason for the season is axial parallelism. And the idea here is a little bit more complicated as words, a little bit easier to understand if we actually can see an image, and we'll do that on the following slides. Axial parallelism, the idea here is the axis maintains its alignment. It stays the same during that orbit or during that revolution around the Sun. We use this to explain axial parallelism, and so we'll pick 4 different times throughout the year to show this. And so as Earth orbits around the Sun, the axis, the tilt remains the same. It does not change. So we can see that represented here in each of these individual dates, these key dates. And so axial parallelism. And so if you look at, think of the axes, and each of these they're parallel. So the white lines indicate kind of these parallel lines to each other, thus the name axial parallelism.